when we say we have a function, it's kind of a special equation, right? Just for example, f of x equals x squared minus 7x plus 3, we say is a function with the name of it here is f. And the reason we call it a function is the input value that we put in there, the x, comes out with only one output value, or can only come out with one output value. Every input value just gets one output value. So most of the equations that we look at in this course, with some exception, will be that, will be a function. And so that's what I wanted to start here with. Just reviewing some stuff about the functions that we'll in particular be interested in. So on functions, there's the domain and there's the range, right? The domain, that's technically the input values, the set of input values. Most often it's the x values. Right? We will look at some where the input values are times t, we'll call them, but generally speaking, it's the x values. And the range, what is the range? The output values that come out. And so in my particular example, it's the f of x values that you get out. Which also brings up, the other form of this equation that we would possibly see would be y equals x squared minus 7x plus 3. Same thing, and so what is y? Well, y is the f of x. Y and f of x are interchangeable there, so. Now, if it may ask you for domains and ranges in this section here, so let's just talk about. Let me change it up. It's pretty much the same, but let's change our function to f of x equals x squared plus 2x plus 5, and figure out the domain and the range. Well, the domain, a lot of times you can get the domain by just looking at the function itself, and really what you're looking for there is maybe like a restriction on the domain, which those are the x values. Is there any x value as far as a real number that I could not plug in there? If I plug in x is 1, or is there a number that I couldn't plug in there and get a number out? No. It's all real numbers, right? One way to describe it. Where you would have a restriction on your domain would be like f of x equals x minus 3 over x minus 2. There, your domain would be restricted because x can't be equal to 2, and so that would make the denominator 0. And so when you're looking at the domain, that's kind of the restrictions. If you have a square root, you may have some numbers you can't plug in because you get the square root of a negative number, things like that. Okay, you're looking for a restriction. This has no restriction. You can plug in any x there. And the other thing now. It's on several occasions for this. We'll be using word description's fine, but in a lot of cases we'll want what's called the interval notation. And the interval notation, of course, for all real numbers is negative infinity to positive infinity. There is no left or right endpoint. It goes infinitely back and infinitely forward. So we could use either one of those, either or on that. Now the range, probably you'd want to graph this out, and so use your calculator or graph it by hand, whatever. So if I look at the graph of this one, it would probably help me explain what the range is. It's the y values that I'm looking at on that. So yeah, we can graph this by hand. All right, so it's up here. And it looks like this point here looks like it's at -1 and 4. Is that right? Yeah. It's that vertex or low point there. Okay. And so, yeah, when we're dealing with the range, we're looking at the y-axis, seeing where the y-axis is covered for values in this case. So there are no y values down here, are there? Nothing below 4. It's all 4 and above is the range here of this this particular function, because yeah, the y values are up here, starting at 4 and on up. So how would you write that? Well, there's a couple ways. We could say y has to be greater than or equal to 4. It is equal to 4, possibly, because that's the point there. But again, the interval notation way, well, you start at 4 and go to infinity. So 4, infinity, and of course, you know the drill on the square bracket. What does that mean? Includes the endpoint. If we put this, technically it doesn't include the endpoint there, so we want to include 4 here. So 4 to infinity, okay? All right, now, using the same example here, just again, getting back to the swing of it on some things. So for this function, let's evaluate f of 5, or f parentheses 5. So what does that mean? That's our input value, right? And so this goes in for the x. So we input 5 into our little function there. So you got 5 squared plus 2 times 5 plus 5. So that's 25 plus 10 plus 5, which works out, is that 40? Yes. All right. So input is what that means for us to do. Now, the ones that, well, we'll do that, input numbers, but other times we'll be interested in this. F of, and then we've got an expression in the parentheses. What does that mean to do? Same thing, right? Here is our input x plus 3, so back in our function, that's what we're going to put in. F of x plus 3 we're just going to put in x plus 3 instead of a number. It's an expression. So you got x plus 3 squared plus 2 times x plus 3 plus 5. Right? Every week at the x, you put in x plus 3. And that's a pretty good answer, but typically what they'll want then is go ahead and simplify that, expand it, and distribute and all that good stuff. I don't think I mentioned it yet in this class, but x plus 3 squared, that's just not squaring both of those, right? Because what this means is x plus 3 twice, and so we've got a little FOIL action there, I call it. You got to FOIL it out, or you may know a shortcut method, but yeah, you got to FOIL that out. X times x is x squared, x times 3, 3x, then the inner 3 times x is 3x, and then 3 times 3, you got 9. So yeah, you you got a little more than just x squared and 9 there. Sure, know that. Over here, yeah, you got a little distributing, so you got enough space here. 2x plus 6, and then plus the 5, and then you just combine the like terms there. You got x squared, then you got what, 8x and 20. Believe that?
Yes.
Yeah. Okay. Thank you. Now, one other particular problem I think they might have you do here in the homework I have for this particular section. So same function. What are the values where f of x equals 7? And so let's talk about that, because something else comes up here that we need to review. Yeah, so in this case, we're not given the input value, we're given the output value. We're given the f of x value as 7, and so that's where the 7 goes, right? It goes in the place of the f of x. So we've got 7 equals x squared plus 2x plus 5. And that gives us the thing to solve. Now, that's a little more involved here because it's an equation we have to solve. It's not just evaluating this one. And what comes up here, so this is an x squared, and so you got factoring, square root method. We'll talk about those. Those will all come up at some point or another. But in this particular case, I don't think either one of those remind you of quadratic formula, right? That's, you know, the solutions are negative b plus or minus square root of b squared minus 4ac all over 2a. Perhaps you know a jingle. Helps you remember that. If anybody wants to sing it, go right ahead. But no, I think that's what's going to come up here, because factoring doesn't work and square root method. We'll talk about those eventually. But for this particular one, I think we're going to have to use that. And to use that, though, you have to have one side 0, don't you? So I need to subtract this 7 and make it 0 equals x squared plus 2x minus 2. Now we know for the quadratic formula, a equals is just the x squared coefficient is 1. B is the x coefficient, which is 2, and c is the constant, which is -2 there. Yeah, so I don't think we have to use it a whole lot, but it does from time to time surface, so be sure. Got the old quadratic formula in hand there. All right, so what do we got here? Negative b, so it's the opposite of b, so it'll be -2 plus or minus square root of b squared, which would be 2 squared, which would be 4, minus 4 times a times c. So a is 1, c is -2, so minus 4 times 1 times -2, you can write down, but that's going to be plus 8. And then all over 2a, 2 times 1 is 2. So you got -2 plus or minus square root of 12 over 2. Pretty good answer. Sometimes they want us to round. Sometimes they want us to simplify. Where you simplify would be the square root here, first of all. Square root of 12, you can break that down as square root of 4 times square root of 3, so that's -2 plus or minus. The square root of 4 is 2. Square root of 3, you can't break that down, but and that's divided by 2. With me there. And then last but not least, looking at, wait, don't look at the square root, but if you look at these 3 parts here, they all can be reduced or divided by 2. So that's -1, +1, +1. And so, those ones you don't have to write. Long story short, those are the solutions right there. Question or concern? Yeah, sometimes the old quadratic formula rears its head there.